It is good to see you again. I have my African attire today. So, welcome to lesson 8 of block 1 sequence. I'll share my screen. So, in your previous lesson, you learned uh, explaining sequences, the term to term rule of sequences in words. So, today, you're going to learn about finding missing numbers within sequences. But before we start, as usual, I would like you to recall what you learned before by doing the retrieval practice. This should take you about 3 minutes. If you cannot finish in 3 minutes, you can pause it and do it at your own pace. Okay, we have 2 minutes left. Okay, it's time to check our answers. Okay, the first one we're told that add 5, then multiply by 2 each time. If the first term is 3, find the first 5 terms of the sequence. Okay, I'll just do a couple of them and then I'll produce the answers, just show the answers. So we add 5, then multiply by 2. If the first term is 3, okay, if we add 5 to 3, that will be 8. 8 times 2 will be 16. Okay, remember, the rule is add 5, then multiply by 2. If we add 5 to 16, that will be 21. Double of 21, which is 21 times 2, that will be 42. Okay, so that's how you generate the sequence. Okay, I'll just produce the answers so that we can make progress in our lesson. However, I need to rub this off so that it doesn't obstruct other aspects of our slide. Okay, so here are the answers. Okay, so does the rule describe a linear or non-linear sequence? It's non-linear. You can clearly see that. So remember, I'll remind you of what we learned in our previous lessons. A linear sequence would have a constant difference. So the numbers by which the sequence is changing from one term to the next will remain the same. But in this case, we don't have that. Number 3, describe the same sequence using a different rule. Okay, we can say, for example, here, you can see this is the first term. We can say multiply by 2, then add 10. Okay, so if we start by 3, we can multiply 3 by 2. That will be 6 plus 10. All right. And then this one, if we multiply by 2, that will be 32 plus 10, 42. So remember, this takes us to what we learned in our previous lesson. You can describe a sequence using more than one rule. Okay, let's do some new learning. Remember, the title of our lesson is to find missing numbers within sequences. So first, we're going to learn how to find missing numbers within linear sequences, and then we'll move on to geometric sequences. We're even going to learn what geometric sequences really means. Although some of you may already know that from SATs or from your earlier learning. So here is a linear sequence, 45, 51, 57. How could we find the fifth term? Okay, so take note that before, I would simply ask you to find the fourth term. That would be easy because you know what you're adding each time, but we have made a jump. Okay, we're asking you to find the fifth term. Okay, we'll do that by continuing the sequence because this one is not far out. We can find the fourth term and then just find the fifth term. But what if we were asked to find the 10th term? Okay, how could we find, could we find the sixth term by doubling 57? Obviously not. It's not going to work. Okay, no, the sixth term is 75 because if we double 57, we're not going to get the sixth term. It wouldn't be correct. So how could we find the 10th term without working out the terms in between? Because think about it. This is the third term. If I ask you to find the 10th term, are we going to keep adding numbers each time? All right, the constant difference. Are we going to keep adding until we get to the 10th term? That is not an efficient way of doing things. It's not a smart way of doing things. So that is what you're going to learn in today's lesson. Being able to find the terms of a sequence that is far out. Okay, there is a method to doing it. Okay, so to find the 10th term without working out the terms in between, we need to know what the constant difference is. So you can see that the constant difference is 6. Yeah, so why? So you can see one difference. Okay, that's 6. Okay, if we add another one. Okay, so take note of what is happening. When we are on the third term, we have already added 2 lots of 6. So let me explain what's going on. So when we're on the third term, okay, remember what we want to do. We want to find the 10th term that is far out. So the first thing, step 1, you need to know what the constant difference is for your linear sequence. So we found out that the constant difference is 6. Okay. Now take note, there is a pattern I want to show you. Remember, maths, when you observe patterns, you can really do some clever things. So here we have to add 6 to get from there to there. To get from here to here, we have to add 6. So, but take note, we have 3 terms. So to get from the first term to the third term, we've made 2 lots of constant difference, of the constant difference. Now, you may begin to see a pattern. By the time we are on the fourth term, we would have made 3 jumps, okay? We would have added 3 lots of the constant difference. And I'm sure you'll be thinking right now that, okay, I think I get this. When I'm on the fourth term, okay, when okay, so here to get from here to here, so we've added 6 there, 6 there, so we'll have 1, 2, so 1, 2, 3, okay, and then if we keep going, yeah, so by the time we get to the 10th term, we would have added 9 lots of the constant difference. So when we were on the 6th term, we would have added 5 lots. So let me write it out. So first term, I'll write it here. So first term, second, third, fourth, fifth, sixth. Okay. So to get from here to here, 1 lot, 6, 2 lot, 6, 3 lot, 6, 4 lot, 6, 5 lot, 6. Okay. So I'm sure you spotted the pattern. Every time we're looking for the term of a sequence, we would have added 1 less number of lots of the constant difference. And that is what we're going to do. Okay. So if we know that this term is 45, the first term is 45, okay, and then we have to add 9 lots because we're trying to get to the 10th term, so it's going to be 1 less. So if we have to add 9 lots of 6, it means the 10th term, to get the 10th term, we'll have to add 9 lots of 6 to 45 to get the 10th term. So, and then 9 times 6 is 54. So you see that if we add 54 to that, our answer will be 99. Okay, so we do not need to keep working. All right, we do not need to keep working from the first term, second term, third term, fourth term, all the way till we get to 10, the 10th term. It's not a smart way of doing things. So here is what we've learned so far. Number 1, when you have to make such a jump to find the missing term of a sequence that is far out, know that number 1 of a linear sequence, remember we're doing linear sequence first, know that first thing first, you need to know what the constant difference is. Next, you need to know the term of the sequence you're looking for. Okay, so if you're looking for example, the 6th term far out, you know that you're going to be adding, okay, it's going to be 1 less the number of lots of the constant difference you're going to be adding. So if you're looking for the 6th term, it means you have to add 5 lots of the constant difference. If you're looking for the 7th term, it means you need to add 6 lots of the constant difference. If you're looking for the 11th term, it means you're going to add 10 lots of the constant difference. Okay, that's what this whole example is about. You need to understand that pattern because it's so important. All right, so here is this one. We're told work out the missing values in the linear sequence. Okay, you're thinking, wow, this one is interesting. We know the first term, but we have a missing, we have, the second term and the third term missing. How do we go about this? Again, we use the same idea. So you need to think, okay, obviously this sequence is a decreasing sequence. The sequence is decreasing. So you say, okay, what's the difference between making the jump from the first term to the fourth term? Because it's the first term, the second term, third term. What's the difference? Okay. Now you need to think, okay, how many lots of the constant difference am I going to add to get there? So I want you to have a think. What's the difference between 80 and 53? Okay. So the difference between 80 and 53 is 27. But remember what we said, anytime you're making a jump, okay, we're making a jump of four terms, it means we're going to add three lots. Remember, it's always one less. So you have to be thinking, okay, I have 27, but need to make three lots out of 27. So another way of thinking about it is to say 27 divided by 3. That will now give you the constant difference, and then it will be easy to find out what the second term is. So you see that? Okay. It's 9 because 27 divided by 3 is 9. And then you can find the other missing terms by just adding 9. Okay. Okay. So far, what we've learned before you attempt the questions is to find the missing terms of a linear sequence. You need, number one, step one, you need to know the constant difference. So this is if you're given the first term, the second term, where you can easily find the constant difference, and then you have to find a missing term far out. Step one, you need to know the constant difference. Step two, you need to know that if you're looking, for example, for the fifth term, which is far out, you know that you're going to be adding three lots. It's always one less. Okay, there's always one less of the number of lots of the constant difference you need to add from the first term to get to that fourth term. For example, if you're looking for the 10th term, it means you're going to add from the first term to get to the 10th term, you're going to add 9 lots of the constant difference. But what if we have the first term and we have missing terms in between? And then you have a term given to you that is far out. You need to find again the difference between the first term and that term, and then figure out the number of lots, knowing that there is always one less. Okay, and then from that, you can divide that number by the number of lots of the constant difference that you need, and then that gives you your constant difference. Okay, and then you can then add from the first term to get the other terms of the sequence, which is this one here. Okay, I'll let you have a go at questions 1 to 4. This should take you 6 minutes. Okay, we have 3 minutes left. Okay, we have 2 minutes left, guys. Okay, let's look at the answers. So here for the first one, we've been asked, Dora and Eva are finding missing terms in the sequence 23, 32, and 41. So we've been asked to check who is correct. Of course, Dora is correct because you can see that if we have to, okay, to get from the third term to the fourth term, okay, we need to um, add 9. To get to the fifth term, we need to add another 9. And then from the fifth to the sixth term, we need to add another 9. So she's right. Okay. So Dora says we need to add 9 3 more times. So she's right. Okay, this one. We're told to find the missing sequence. I'll do the first one and then I'll just go ahead to review the answers. So this is the first term, right? So we know that to get from the first to the 10th term, we need to add 9 lots of whatever is going on with the constant difference. With the constant difference, we can see that we're taking away 8 every time. So it means to get to the 10th term, we need to take away 9 lots of 8, which is 72. Okay, 9 lots of 8 is 72. So it's like saying 100 minus 72. Okay, that should be 8. You can take away that. So you borrow from here. That's now 10. Okay, and then that's now, you borrow from here. That's now 9. So that's 8. And then that's 28. So your 10th term should be 28. Okay. Then this one you told what is when what is the last positive term in the sequence. Okay, you find that by actually going on to decrease the sequence as it shows until you find the last positive term, and then they're asking you which is the first negative term. Okay, one way you can do that is to actually make a jump to say, okay, I know, the next one isn't going to be, so maybe you can make a jump to the sixth term to check whether you get a really small positive number. Okay, you can be making jumps, knowing how we, find out the number of lots of the constant difference that we need to do to use to get the term of that sequence. So that's how you do it. And then these ones, I'll do this one. Okay, and then I'll go ahead and reveal the answers. So this one, you can clearly see that we have the fourth term. So we have first term, second term, third term, fourth term. So it means we're going to be adding 3 lots of the constant difference, but we don't know the constant difference. What we know is the difference between 4 and 16. Okay, the difference between 4 and 16 is 12. All right. And then we know that because we have 4 terms, we're going to be doing 3 lots of the constant difference. So it's like saying 12 divided by 3 is 4. So to get this one, you're going to be adding 4. So that's 8. And then that's 12. Okay. Okay. I'll reveal the answers to save time so that we can move on to other aspects of our lesson. All right. Okay. So here are the answers. All right. You can mark your work now. So this one is particularly interesting. Let's go back. This one, I'll just explain this one quickly. So this one, you can see we have 1, 2, 3, 4, 5. So we have 5 terms. Okay. So I would like to, because this is a very important skill. So any opportunity I have to demonstrate how they got the answer, I would want to do that very quickly. So this is 5,200. This is 4,000. So 5,200 minus 4,000 is 1,200, right? But we have 1, 2, 3, 4, 5. Okay, so we have 1,200 to be divided by 5. That will give you your constant difference. Okay, and then that is what you then add each time. Okay, so which will be 300. So you have 4,000, then you have 300, so on and so forth. Okay. Um, yeah, that's right. Yeah. Okay. So let's move on. So here, the next term in a geometric sequence is generated by multiplying by the same number each time. So we've worked, on how to find the missing terms in linear sequences. We're now working with geometric sequences. So for geometric sequences, you need to know that a geometric sequence is generated by multiplying by the same number each time. Okay. So for example, here you can see that we're multiplying by 2 every time. Okay. This is a geometric sequence. So if you're told to find the next 2 terms in the sequence, you can just multiply by 2. Okay. Then this one, it's also possible to multiply by a fraction. So here, because take note, if So here you see that it looks like we're dividing by 3. Okay, but take note that dividing by 3 is the same thing as multiplying by 1/3. Okay, so it's still a geometric sequence. So I want you to have a go at the rest of the questions. So we have 1, 2, 3, 4, 5. It should take you about 7 minutes. Okay, we have 2 minutes left. Okay, it's time to check our answers. Okay, so for the first one, so remember some of the questions, I'm going to skip it. I will explain especially the geometric sequence because I think that is the one that students often find a little bit confusing. So I will try to explain that as much as I can. Uh, but the other ones, I'll just go through them really quickly and then reveal the answer. So this one, it's clear that you multiplying by 10 every time. This one is obvious that you're dividing by 5 every time. Okay, because if you divide 100 by 5, you have 20. 20 divided by 5 will be 4. Okay, then this one, question 6, you ask a sequence starts with this. Of course, you've been told Jack is incorrect because it's not going to be always decimal numbers, but you're told to find the first integer term. So you're going to have to, find, the common difference is we're adding 0.7. So you're going to have to keep doing that until you find the first integer term. Okay, there are different ways to do this, but I'll just, for now, at this elementary, foundational stage, I would like you to stick to using the basic method of continuing to add each time until you get to the integer term and the decimal term which they've asked you to look for. Okay. And then for question 7, you're told the first term of a linear sequence is 17. The fifth term of the sequence is 29. Yeah. What is the ninth term of the sequence? Okay, let me just do this one really quick. So you have the first term is 17. Sorry, need a pen. The first term is 17. The fifth term is 29. So 29 minus 17. Okay, 9 minus 7 is 2. Is 12, right? Now, to get from the first term to the fifth term, remember what I told you, key skill, it's always one less. Okay, so we're going to have 4 lots of the constant difference, but we don't know the constant difference yet. Okay, so to know the constant difference, we'll have to do 12 divided by 4, so which is 3. Okay, so the constant difference is 3. So if we're being asked what the ninth term of the sequence will be, remember to get from the first term to the ninth term, there's always one less that we use. So we're going to have 8 lots of the constant difference, which is 3. So 8 times 3 is 24. So to get to the ninth term, we have to add 24 to 17. Okay, so 24 plus 17, that's 1. 4 plus 7 is 1. 1 carry 4 plus 7 is 11. 1 carry 1. 1 plus the 2 is 3 plus this one, 41. So you can see the answer is 41. So let me just show you quick. All right, you can see question 7, the answer is 41. Okay, this one, question 8. The arithmetic sequence, you should know how to do that by now. I don't want to repeat that because I've shown several examples of how to do that. So for example, this one, you just need to do the difference. Just a minute, let me rub this off. So for this one, the first one, you just need to do 192 minus 24. Okay, you just need to do 192 minus 24. And then you know that, okay, 192 is the 4th term. So you have 1, 2, 3, 4. So remember, it's always one less, right? Always one less. So we don't know the constant difference. So we know 192 minus 24, that number you have is going to be divided by 3. Okay, so that you actually know the constant difference from this one to the next one, and then you can just add that constant difference. Okay, but I really want to explain the geometric sequence, how it actually works, why the answer is what it is. Because if you take note of the answer, you would see that the answer for 8, okay, the answer for this one, you would see that it is 2448. Okay, but how did we get this answer? How does it actually work? Okay, remember the examples we looked at for geometric sequence. I only just told you that geometric sequence, you get it by multiplying each term by a constant number. Okay, here is how it works. If I told you that there is a sequence, so if I told you that there is a sequence that we're multiplying by 2 every time, if I say 2, 4, yeah. So remember, a geometric sequence, you're multiplying by the same number every time. So 2, 4, 8, okay, 16, okay. Let's say I skipped this one. You do not know what they are, which is a bit like this one, yeah. So if I am multiplying by 2 every time, what if I did 16 divided by 2, which is 8? What does that tell you? Does this 8 tell you? This 8 tells you that by multiplying by 2 every time, is telling you the number of lots, okay? How much you multiply by the first term to get to this term. Okay? So I'll repeat. This is telling you, so imagine this is not there. I'll repeat exactly what I explained. Yeah? If I do 16 divided by 2, that's 8. That is telling you what you would have to multiply 2 by to get to 16. That's another way of thinking about it. Okay, now if that is the case, how many jumps? Remember, this is my fourth term. So once I know that this is my first term, okay, this is my second term, the third I do not know, but I know the fourth. It's the same principle. So we have the fourth term, so we're going to have one less. So it means I need to find a way to say, okay, I need to multiply 2 by 8 to get to this number 16, but I need to find a way to split it between 3. Yeah, between 3 jumps. I need to make a 3 jumps of that number that I'm going to be multiplying by. So another way to think about it is to say, okay, I need to multiply by 8, but I need to think about what number will I multiply by itself 3 times, 3 lots to get to 8, right? And that is how we got this number, because if I do 192 divided by 24, I'm going to get 8, right? Now, remember, this is the fourth term, and remember, it's going to be 1 less. Remember that technique we learned from linear sequence. So I have to think, okay, 24 times 8 is what will give me this number. What will I need to multiply by itself 3 times to get 8, right? Because remember, you made 3 jumps all the way to here. So remember, those 3 jumps has to be broken down into 3 lots to get here. Okay, so we know the number is 2, obviously. So if you do 24 times 2 is 48, and that is how we got this answer here. So geometric sequence can be a little bit tricky, but it's actually very easy, as I have just shown you, okay, to find the missing terms. Okay, here are the answers. Mark your work. Okay, that brings us to the end of our lesson. Okay, so what have we learned so far? So we have learned how you can find missing terms of linear and geometric sequences. For linear sequences, you have to find, step one, you have to find the constant difference. If you know the constant difference, if, for example, you're looking for the 10 term, you know that you need to get the 10 term, you're going to have one less, okay, of the number of lots of the constant difference you need to have add to the first term to get to the 10 term. If you're looking for the fifth term, you need to do 4 lots of the constant difference. But if you're looking for the constant difference, for example, in between, you need to find the difference. So, for example, if you have the first term and you have the fifth term, you can take away the first term from the fifth term, but you know that you're going to have one less, right? You know, we always have that technique. So it means to find the constant difference, you're going to have to divide by 4. Okay. Once you find the difference between the fifth and the first term, you're going to have to divide by 4 to find the constant difference, and then you can get the terms in between. For the geometric sequence, we use the same technique. So remember, geometric sequence, you get it by multiplying by the same term every time. So if you have a missing term, like we did, I showed you from the last example, or as I explained from the last question you had, you just need to divide. Okay, let's say, for example, you have the first and the fourth term. You just need to divide the fourth term by the first term to find the number that you use to multiply the first term to get to that fourth term. And then remember, there's always one less. Okay, so you now need to think, okay, what number will I multiply by itself every time? Because remember, the number has to stay the same to get that number that you got when you divided the fourth term by the first term. Okay, so you need to, if you don't understand this, you need to go through again, watch the video again, especially the last explanation I did. Okay, all right, until next time, take care. Bye bye now.